run you through maybe a couple supplementary examples just to help you guys out with your power laws. Okay, so why don't we just we'll start at the easiest one, right? So let's just maybe do 7 to the power of 0. Okay, anything to the power of 0 is going to equal 1. Doesn't matter what it is. Doesn't matter if it's 1,355,363 to the power of 0. That's equal 1. Okay, so you're just going to know that, right? It also doesn't matter if you have something like a fraction to the power of 0. Oops. To the power of 0. That's also going to equal 1. Doesn't matter. Okay. And then for something that's like basis to basis, right? So you're going to have something like maybe 4 to the negative 2 multiplied by 4 to the power of 5, right? We know that when we multiply things of the same base, we have to add the exponents, right? That's what happens. So you're basically going to get 4 to the positive 3, right? Negative 2 plus 5, which is going to equal 4 to the power of 3, which is going to equal, right? So this would be kind of your work's done now, right? 4 to the power of 3 we know is just 4 times 4 times 4. Okay? And so I know that 4 times 4 is going to be 16 times 4 is going to be 64 is going to be my answer for this question. Okay? The exact opposite would be true if I were to take a question like 3 to the power of 6 divided by 3 to the power of 3. Okay, well, in this instance, you have to do, the bases are the same, right? The 3 and the 3. Okay, so you're going to have to do 3, 6. Okay, but what I do here, when I have division, I apply what we call quotient rule, and we're going to subtract the exponents. So it's going to be 3 to the power of 3. Okay? And then that's going to equal, you could do this one of two ways, right? You could go 3 times 3 times 3, right? That's going to equal 9 times 3, which is going to equal to 27. You could do it that way, or you can jump to your calculator and just go 3 xn 3, 27. Okay, so either of those two methods will work. Okay, now the only way for me to make that a little trickier is what if I made the denominator, or the exponent in the denominator, if I went like this. I'll make a new question. 2 to the 2 over 2 to the negative 2. Okay, I could even make it a 3 just so you don't get confused. What this means is I'm going to go, bases are the same, so it's 2, and then I'm going to go 2 to the, and then minus, because it's quotient, but the other one is a negative. Okay, so what you're going to have to actually do is it's going to be 2 to the power of 2 plus 3, which is going to equal 2 to the 5. Okay, which you type into your calculator and you can go 2xn to the 5. 32. Okay, and then there's just one for some of the challenging questions. The challenging questions can be done in a way that is a little bit more dealing with fractions, right? So just as a little reminder, the fractions, anytime I have fractions like 2 over 3 and I want to multiply them together, like let's say 4 over 5. Anytime you multiply fractions, you always multiply the tops together and you always multiply the bottoms together. Okay, so your answer here, your answer in this instance is going to be 8 over 15. Okay, so we can apply this to something like if I were to make up a question, x, I'm going to show you one more thing before we do that. So if we go x, remember, one of the other things we can do is xy multiplied by x squared y. Okay, this is the exact same thing. We can apply the exact same rules, right? You're just going to highlight which bases you have that are the same. Okay, and so what ends up happening, doesn't matter what the base is, just as it's the same is the important part. So you're going to get x, there's an imaginary 1 on both of these, okay, and it's going to be x to the power of 1 plus 2 multiplied by y to the 1 plus 1. And so we're going to get x cubed y squared. Okay, so that's important because you need to know you're just matching up bases, right? And then if I come down here, I can make one challenging question, and I'll use the same as the top here. X, y multiplied by x squared y. But what if I wanted to divide by x squared y? Not a good example. X squared y squared. What would you do? Well, you'd apply the exact same thing that you did up here, all this work, to get an answer, right? It's because the numerators are going to be the same, if you can see that, right? And so what you're going to get in the top is going to be x cubed y squared, and then what you're going to do is divide by x squared y squared, because that's what's down here in the bottom, right? And so now you can just do the math on that, because I see that the bases match up with the x's, and they also match up with the y's. So let's just do our exponent laws on this, and then we'll get a final answer. So it's going to be x3 minus 2, and then y2 minus 2, right? And so if I bring this down here, I'm going to get x3 minus 2 is 1, and y2 minus 2 is 0. Okay, anything to the power of 0 is equal to 1. And so your answer is just going to be x, right? Because this is going to be 1. So it's going to be x times 1, which is going to equal x. Okay, and that's your final answer. Okay, so that's your power laws. This is a little supplementary video to help you guys out a little bit with maybe even the quiz that's sitting there. Okay, so do that if you haven't, and then that's probably all you need to know. That's all you need to know from exponents, right? Is be able to apply your power laws. Okay, so that's it for this little supplementary video, and let me know if you have any questions.